All right, so let's take a look at this last category here. Again, we're calling it special. Again, it's not necessarily that it's especially hard, just a little different look because what if you have a problem that's got a term on the outside like this 3x, and then it's got a radical, in other words, a term that's on the inside like the square root of 45x to the fifth. Now, again, notice that we've got some parts that are on the outside and some parts on the inside. And what we want to do here is not make up a rule that says that somehow we're able to take what's on the outside and bring it to the inside. You've actually never seen that, but you have seen some items that are on the inside be able to come out to the outside. And so that's what we're going to want to do. We're going to want to work on splitting up this 45 and this x to the fifth so we can bring something out. And then it'll end up meeting this 3x that's out here. Now, remember, when you split up 45, you want to think of a perfect square number that's inside of 45, because since this is a square root, and I hope that you arrive at the number 9. Now, 9 times 5 is still 45. When you think of x to the fifth, you want to think of the highest number inside of this 5 that's able to divide with this 2. And so the highest number inside of 5 is a 4. Of course, you still have this plain x to the first power left behind. Now, both of these guys are the ones that get their ticket to freedom. They're able to come to the outside. And so when they come to the outside, they're going to eventually interact with this 3x. But let's bring them to the outside. Let's bring the 9 to the outside. You want to do the square root of 9, so that's going to turn into 3. And let's bring this x to the fourth to the outside. That's going to divide by 2. And so the 4, when it divides by 2, leaves us with x squared. Okay, now the 5 is left behind, the x is left behind. But now that we're on the outside of this expression, we're able to simplify. And so, yeah, you can simplify 3x times 3x squared. You would multiply the numbers, and you would add the exponents. So you end up with 9x cubed, and then root 5x. All right, this will be the last problem that we look at in sort of this special category. Now, what we have here is the cube root of x to the 8th times the fifth root of x to the 15th. Now, it should catch your attention that these two roots, these are different, and the product rule always required these roots to be the same. So again, we don't want to make up a new rule. We don't want to say, we'll just multiply these together anyway. No, you can't multiply and pull it together if the roots are different. But what you can do is you can kind of observe that there's some math that can be done as is. In other words, this cube root of x to the 8, I can do that. I can take out some of that x. Now, you want to always think about the largest amount of x inside of 8 that can divide by, in this case, by this 3. And the largest amount of x would be x to the 6. Now that leaves you with x squared beside that x to the 6. So I can take out this x6. Remember, when you take it out, you divide it. And that's going to end up being x squared. Okay, because I divide those two numbers. But I'm still left behind. With this x squared. Now, what about over here? What about this fifth root of x to the 15th? Do you realize that whole thing can be taken out? Because 15 is already divisible by 5. So I take out that entire x to the 15th. We divide it. We divide it by the 5. That's that root. And we end up with an x to the third. Now, at this time, what's left is we have two numbers that are, well, they're actually variables, but they're both on the outside. And when numbers are on the outside, they are free to combine. And so when we combine these x squareds and x cubes together, we're going to add the exponents. So we end up with x to the fifth, because you add those exponents. And then this cube root of x squared, well, it's just left behind, and it's beside your answer. Now, your next objective would be to take a look at the homework, the problems that are attached to this day. Try them. Try them on your own. Try them, see where your questions are. And then you'll be able to view the homework explanation video and see how you did. But try the homework first. View the video second. and then I'll provide one more optional practice activity so you can continue to work out this product rule.